Boys and girls, this is Mr. Manise here again with another super cool video, and boys and girls, this is the one. This is, without a doubt, in my honest, humble opinion, this is the hardest test and the hardest material that we cover in all of advanced algebra. So it's almost like I want to say that guy that gets in the boxing ring before a boxing match, let's get ready to rumble. That's kind of what I feel like here. This might be a 2-hour video. Okay, I'm just kidding. It's probably only be like maybe an hour and 55 minutes or something like that. But I'm just going to say, guys, before I get started, this stuff is hard, okay? If you can do this stuff, then companies want to hire you. And I know I say that in class, but I just want to reiterate that because this is really difficult stuff. And when you can navigate and work these types of problems with all these details and so many places to make mistakes, if you can navigate through this and master these concepts, guys, then people want you working for them. I worked for a company for 10 years, and I'm looking at you guys, and I want to hire you guys because I know you can do this. You can do it. You've got to tell yourself you can do it. My disclaimer, as always, is I need you guys to work these problems on your own and then come to the video and see where you might have had any misunderstandings. So without further ado, let's begin. So in this first one here, they want us to, the first four, they want us to perform the given operations and simplify. Notice in these four problems, there is no equal sign. I'm not trying to solve anything. I'm just trying to simplify my expression to get it down into a smaller, condensed, simpler form. I'll say they want us to state the excluded values. All right, so remember that those are the values that will give us a 0 in the denominator, which we can't have because we can't divide by 0 because that is undefined. All right, so number one here. See that bad boy right there? In fact, for these problems that don't have equal signs when they're simplifying, I want you guys to put boxes around the operations, okay? It's asking about an operation. That bad boy, that's a division sign. That bad boy, that is an addition sign. Subtraction, okay? So these operations make all the difference between whether or not we need a common denominator. That bad boy right there, that's multiplication. When you multiply stuff together, and remember, these are rational functions. So this word rational basically means fraction. Fractional functions, fractional expressions. Okay, so when I'm multiplying two fractions together, if I'm multiplying 3/7 times 2/5, there's no common denominator here. You just multiply across the top, multiply across the bottom. Okay, there's nothing to do there. All right, so that's all I'm going to do here. So I've got to figure out before I start multiplying and start canceling and simplifying, I'm always looking to see, can I simplify, can I factor, can I pull out a GCF? So you guys are probably looking at this and saying, oh, I can factor that, 2 and 4. You're so used to seeing that, but when you stop and think for a second, wait a minute. What are the factors of 4 that add to 2? The only factors of positive 4 are 1 and 4 and 2 and 2, and neither of those add to 2. Okay, so don't want you guys to fall into that trap on the first one. So I can't do anything with that numerator. I can't do anything in the denominator with 10x. So now I'm focused over here, 4x plus 20. What can I do there? So there I can pull out a GCF of 4. That's going to leave me with x plus 5. Over here I'm just going to write down what I have because I can't do anything with the left side. Okay, times. And then on the bottom, what are the factors of 10 to add to 7? That's 2 and 5. So this is going to factor as x plus 5 times x plus 10. All right. And now I'm looking to see, okay, I'm multiplying across the top, multiplying all that together, I'm multiplying all that together, what can cancel? And remember, I can cancel diagonally. Just like if I had 2 times 3 times 4 times 5 divided by 5 times 1 times 7, I can cancel way over here because I'm multiplying all that stuff together and multiplying all that stuff together. They don't have to be right on top of each other. So I have an x plus 5 and an x plus 5. Bye-bye. See you later. Those cancel. And then, so basically all I have left on top is the 4 times all this stuff. Okay, so I'm going to rewrite this as 4 times this whole trinomial, which is x squared plus 2x plus 4. All right, and then on the bottom, I have 10x squared times this x plus 10. 10x squared times x plus 10. But you'll notice here that I have a 4 over a 10. Can I simplify that? Okay, stop and take a few seconds and ask yourself, can I simplify that? And the answer is yes, because I'm multiplying all this stuff together. If I had 4 plus some expression over 10 plus some expression, I cannot cancel those, okay, because that is addition, all right? I can only do that when stuff is being multiplied. They're attached to each other. Okay, so they're attached, so I can simplify 4 over 10. That just simplifies to 2/5. So my final simplified answer is 2 times x squared plus 2x plus 4 over 5x squared times x plus 2. So all I did was I took 4/10 and I reduced it to 2/5. Okay, so that is my simplified expression. All right, they want us to state the excluded values. Tricky here. Okay, so you got to go back and look at everything. Okay, if you make the mistake of going and looking at your final answer, then you'll say, okay, what are the values on the bottom in the denominator that give me a 0? Okay, anytime you have an x by itself, an x squared or an x or whatever, that's always going to give you a 0, because when I set that piece, when I set the 5x squared equal to 0, I'm literally going to get 0. Okay, so one of my excluded values, we'll call it EVs. One of my EVs is going to be 0. And then I'm looking at this piece, x plus 2, and I'm going to flip the sign, right? So if I set that equal to 0, move the 2 to the other side, that's going to be a -2. Okay, so I got 0 and -2. However, you got to look at the beginning of the problem. If you go back up to our original problem, I've got an x plus 5 up here and an x plus 5 down there. You still have to include that, guys. If I stick in a -5, flip the sign. If I stick in a -5, I will get a 0 in the denominator. Okay, if I stick in a -5 here, that will give me a 0. So even though I cancel it, you still have to include those excluded values. Okay, Mr. Moniz, can I check this on my calculator? Yes. Yes, you can. That's why I love math. That's why I love algebra, advanced algebra. Yes, you can check this stuff. Now, for the sake of the video, this is probably going to be a long video. I'm not going to do this for every single one, guys, but let me show you how to do this one, because this one actually is a little bit cumbersome. Okay, it's going to take some time. I'm going to type all that in my calculator. I'm going to get a number using the trick that I've taught you guys all year. All right, so I've got a whole bunch of stuff. So if you've got multiple terms, you need to put all this in parentheses. Okay, so I'm going to go parentheses, x squared plus 2x plus 4, close the parentheses, divided by, I've got to put that in parentheses too, because technically it's two things. I've got a 10 attached to an x squared. Parentheses 10x squared. Okay. I didn't mean to do that. Take 2. Awesome. Awesome. X squared plus 2x plus 4 divided by parentheses 10x squared. 10x squared. Oh my goodness. Okay, all right. Take 3. Oh my gosh. X squared plus 2x plus 4 divided by 10x squared. Close the parentheses. Okay, we can do it. I can do it. Okay, times another set of parentheses, parentheses 4x plus 20, close that parentheses, divided by parentheses x squared plus 7x plus 10, close that parentheses. Oh my gosh, that's a bunch of stuff. Okay, get a number, guys. Don't care what the number is. Do not care if that's a million, -2, or what. Okay, I just need a number. We are saying that that is the same exact thing as our simplified answer. All right, so let's check it out. 2 parentheses x squared plus 2x plus 4, close parentheses, divided by, now here I need 2 sets of parentheses. I've got 2 different things in the denominator, so I need 2 sets of parentheses. You can never get in trouble by using too many parentheses, but you can get in trouble by not using enough. So I got 1 set of parentheses for the 5x squared, close that, times the second set of parentheses, x plus 2, close the double set of parentheses. Oh my goodness, I hope this is right. Oh my gosh, I love it. They match, okay? They match. So when they match, you know you've done the problem correctly. Okay, let's go on to the next one. All right, see that guy right there? That is called a division sign. Okay, when I divide rational expressions, I must multiply by the reciprocal. Okay, 3/4 divided by 2/3 is the same thing as 3/4 times the reciprocal times 3/2. You guys learned that many years ago. It's the same application here. So I'm going to rewrite this as x plus 2 divided by 4x minus 12 times flip. Okay, now I will say, before you flip, you've got to make sure that you're looking at possible excluded values, and we'll see that at the end, but I must look at this guy to see what gives me a 0 before I flip it. Okay, but let's go ahead and flip it. X squared plus 2x minus 15 all over 7x plus 14. Okay, All right, so now I'm looking to see where can I factor stuff. On the top, can't do anything there. Down there, I can pull out a 4. So I'll have the x plus 2 on top times 4. That's going to leave me with x minus 3. I'm just pulling out a GCF of 4 here. Times, how does this factor? What are the factors of negative 15 to add a 2? That is going to be a positive 5 and negative 3. So positive 5 and x minus 3. On the bottom, what can I do? I can pull out a 7. That is going to leave me with x plus 2. All right, let's look and see what I got. Okay, I got an x plus 2. You can put that in parentheses if you want. I got an x plus 2 and x plus 2. Bye-bye. See you later. X minus 3, x minus 3. Bye-bye. Nice knowing you. So on top, I'm left with an x plus 5. And on the bottom, I'm left with 4 times 7, which is 28. Okay, so that's my simplified answer. All right, so for sake of the time, I'll check maybe one more of these. I'll skip this one. Where are my excluded values? Okay, so if I look at my final answer, I don't have any variables in the denominator, right? So you might look at this and say, well, I don't have any excluded values. There's nowhere where it makes it denominator 0. Yeah, but you've got to go back and look before you started canceling stuff. There's an x plus 2, so I got to flip that sign. So one of my EVs is a negative 2. There's a minus 3. Flip that, that's a positive 3, but you got to go all the way back up here. Okay, when I factored this guy, that factored as x plus 5, x minus 3 on the bottom. Okay, so I have to include this guy as one of my potential EVs as well because it was originally on the bottom. So when I flip that sign, that's negative 5. So I actually have 3 excluded values on this one. Okay, see that bad boy right there? That is a plus sign. Okay, when I add 3/7 plus 2/5, okay, I cannot just multiply across the top. I must get a common denominator. Okay, remember, add and subtract, common denominator. Add and subtract, common denominator. All right, so what is my common denominator? This is like x plus 5 over 1. So my common denominator is simply x plus 1. So I'll just come out here and say CD, common denominator is x plus 1. That means I don't have to do anything with this guy. It already has the x plus 1 on the bottom. So for this guy, let me rewrite this so this is not confusing with the little 3 there. Plus x squared minus 4 over x plus 1. Okay, so this guy needs a what? It needs an x plus 1. So that means I got to multiply the top and the bottom by x plus 1. Whatever the common denominator is, you're multiplying by that over itself. X plus 1 over x plus 1 is just a big fat 1. I'm just multiplying by 1. All right, so now this is the tricky part. I saw some students as they were working through their test review not sure what to do here. You got to FOIL this out. This is a binomial times a binomial. You've got to do first x squared, outside 5x, inside x, and last plus 5, okay? And then I'm going to add that to the rest of the stuff, x squared minus 4. And all of this is over my common denominator of what? X plus 1. Okay, so now I'm just going to simplify. This is just regular combining like terms. 1 apple plus 1 apple. X squared plus x squared, I got 2 apples. 2x squared. I've got 5x, 5 grapes plus 1 grape is 6 grapes. Okay, and I've got 5 minus 4, which is plus 1, and all of that's over my common denominator of x plus 1. Okay, so let's check that. I'll check this one. Okay, so let's type in our original problem. I've got x plus 5 plus parentheses, I got a fraction there, x squared minus 4 divided by parentheses x plus 1. Let's get a number. Okay, fine. We think that's the same thing as parentheses 2x squared plus 6x plus 1, close parentheses, divided by x plus 1. Drum roll. Bam, look at that. Beautiful, beautiful. I know I've got that right. I know I did the problem right. All right, so excluded value. All right, I didn't flip anything, so I don't have to look at that. And basically all I have is the x plus 1 on the bottom, so when I change that sign, I just get a negative 1. That's the only value that gives me a 0 at any point in the problem in the denominator. Okay, let's keep going, rocking and rolling. All right, see that bad boy? That is a subtraction sign, okay? Add, subtract, common denominator, add, subtract, common denominator. All right, so before I get a common denominator, let's go ahead and factor anything that we can factor. This is x plus 5 on top. That is a difference of squares, okay? So hopefully you're catching these by now. That is x plus 9, x minus 9, okay, minus 3 over x minus 9. So what's my common denominator? This guy has an x plus 9 and x minus 9. This guy only has an x minus 9. Okay, so this guy is the common denominator is the x plus 9, x minus 9. Okay, so this guy is missing the what? This guy's missing the x plus 9. So I'm going to multiply this, the top and bottom, by x plus 9 over x plus 9. Okay, so I'll just rewrite this. Okay, and then minus, okay, this is tricky. I'm going to hold off on this for just a second. Let's go ahead and distribute here. 3 times x and 3 times 9. This is going to be 3x plus 27. But I am subtracting, this. I'm subtracting the whole thing. I'm subtracting whatever's behind all this stuff. So please, please, please put that in parentheses when you have these rational expression signs where you're subtracting. I'm subtracting the whole thing. So you've got to put that in parentheses over my common denominator of x plus 9, x minus 9. Now I've got to go back and redistribute the negative sign. So I have my original x plus 5. That will become a minus 3x, and this will become a minus 27. And now I can just combine my common denominator. Okay. Now, that's the hard part. Now we just simplify. I've got x minus 3x, so that's going to be negative 2x, and then 5 minus 27 is minus 22 over the common denominator of x plus 9, x minus 9. Okay, remember, I want my final answer fully simplified, so if you can pull out GCFs, you need to do that. So these are both even, right? So I know they're at least divisible by 2. So I can, and that front term is negative, so I'm going to pull out the negative 2. That's going to leave me with x. Negative 22 divided by negative 2 is plus 11. And that will be over x plus 9, x minus 9. And that is my fully simplified answer. Okay, so what about my excluded values? Okay, basically throughout the whole problem, I never flip. Throughout the whole problem, I just have an x plus 9 and x minus 9. So my EVs will be 9 and negative 9. Okay, that is operations with rational expressions. Okay, what is this word right here? What does that say? Equations. See that bad boy right there? That is called an equal sign. Okay, so when you have the equal sign, we are not going to be simplifying anymore. We're actually solving for x. We want to get x is equal to some value. Okay. All right, so the way that we're going to do this is we're still going to use the same concept and process that we used with the rational expressions, the operations with getting a common denominator. All right, and to do that, I'm going to factor everything that I see first. All right, so over here, I'm just going to write the 6 in the numerator. What are the factors of 16 to add to 10? That is going to be 2 and 8. So this will factor as x plus 2 times x plus 8. That is going to be equal to 2 over x plus 2. So this guy has an x plus 2, x plus 8. This guy just has an x plus 2. All right, so that divides evenly into this x plus 8 times. Okay, so my common denominator is the x plus 2 times x plus 8. If you guys are struggling with the common denominator, I have another previous video on rational expressions where I really break down how you get common denominators. So I'd encourage you to go back and watch that video if you're struggling with how to get the common denominator on these things. Okay, so this guy needs a what? It's missing the x plus 8 piece. Okay, so I need to multiply this guy by x plus 8 over x plus 8. Okay, so on the left-hand side, there's nothing to do there. I'll just copy that down. 6 over x plus 2 times x plus 8. And that's going to be equal to, now here I'm going to distribute. 2 times x is 2x, and 2 times 8 is plus 16. Okay, and that's also over my common denominator of x plus 2 times x plus 8. Okay, and as I taught you guys in class, as you learned, when you have a common denominator on the left and the common denominator on the right, what happens to these guys on the bottom? They go away, right? And so we went through that explanation of showing why these common denominators disappear. I won't go back through that again, but basically I'm left with an equation on top. So I have 6 is equal to 2x plus 16. Let's subtract 16 from both sides. 2x is equal to negative 10 divided by 2, and x is equal to negative 5. Mr. Moniz, can I check that? Yes. Okay, but it's not going to be the same thing as up here. When you're simplifying, you just type in your original problem, type in your final answer, and make sure they match. when you have an equation, you actually have to check to make sure this, when you plug this number back in, the equation holds true. Okay, so I'll show you how to do one of these on your calculator. Okay, so we think the answer is -5, so everywhere we see an x, we're going to stick in a -5. I'll just do it on the left first. So I've got 6 divided by parentheses. Now it's a -5. I'm sticking in -5 for x squared, so I'm going to use another set of parentheses, because remember, you can't say -5 squared. Okay, you can't do that because your calculator says that's -25. But if you do -5 with a parentheses squared, that's what gives you the +25. So when I type this in, I'm going to type in 6 divided by parentheses, another set of parentheses, -5 squared, which we know is 25, plus 10 times -5, plus the 16, close the parentheses, and that's going to give us some number. Okay, fine, whatever. Okay, that should be the same thing as the right-hand side. When I do 2 divided by parentheses, -5 plus 2, ta-da, boom. Right answer. Guaranteed you got it right. Okay. Now this also says to check for extraneous solution. What does that mean? Okay, so if you try to dig deep and remember, extraneous solution means that when you get done and you put a box around your answer, if that answer happens to be one of your excluded values, then it becomes an extraneous solution. So in other words, what are my EVs in this problem? My excluded values would be a -2 and a -8, and we got the same thing over here. So -2 and negative, and so in other words, if my final answer was a -8, that can't be right, because if I stick in a -8, that's going to give me a 0 in the denominator, which we can't have. That's not going to be a valid answer. Okay, so just check and make sure that these values that you get when you put the box around it do not give you a 0 in the denominator anywhere, or it's not one of your EVs. Okay, all right, tricky on this one. Or no, actually I was thinking about the next one. This is not bad. Okay, so I got an x plus 1, x minus 1, and an x squared minus 1. So that's the difference of squares. So let's go ahead and rewrite this one. So this is going to be 2 over x plus 1, x minus 1, plus x plus 2 over x plus 1 equals 4 over x minus 1. Okay, so what's my common denominator? I got a plus 1 and a minus 1 over here, and then I just a plus 1 and just a minus 1. So this is my common denominators, both of these, which means this guy's missing a what? That guy's missing an x minus 1, and that guy's missing an x plus 1. So I'm going to try to write this maybe a little bit neater over here. X plus 1, x minus 1. Now this guy needs an x minus 1. So plus x plus 2 over x plus 1. And it needs an x minus 1 over x minus 1. That's going to be equal to 4 over x minus 1. And what does this guy need? This guy needs a plus 1. So multiply by x plus 1 over x plus 1. Okay, now we're going to simplify. So just bring this down. Now what do we do here? X plus 2, x minus 1. We have to FOIL, right? We got to FOIL this out. Okay, so when I FOIL this, that's going to be plus x squared, okay, last, minus x inside, plus 2x minus 2. That's over x plus 1, x minus 1. And that's going to be equal to, distribute here, 4x plus 4 over the common denominator. Okay, now what do we get to do? Bye. See you later. They're all gone. And now I'm left with an equation on top. Okay, so I have, so we got the x squared. Let's see, maybe I should write this up here. I got the x squared. And then I have 2x minus x. Well, that's a plus x. And then I have 2 minus 2. Those guys just cancel. Okay, so I've got an x squared plus negative x plus 2x. That's the plus x. That's going to be equal to the stuff on the right-hand side, 4x plus 4. Okay. All right, so I got a quadratic. How do I solve this? Set it equal to 0. So let's move everything to one side. X squared. If I subtract 4x, that's going to be x minus 4x. So that's going to be minus 3x. Move the 4 to the other side, minus 4, and then I'll just be left with a 0 on the right. Okay, so this is just last year stuff with quadratics. How do I solve that quadratic? Can I factor it? Are there any factors of -4 that add to -3? Yes, Mr. Manice, there are. And that's going to be a -4 and a +1. So x minus 4, x plus 1 equals 0. And what do I do with those signs? Flippy flip. So x equals +4 and -1. Okay, however, what does that say? Check for extraneous solutions. What are my EVs? Okay, so everywhere throughout the whole problem, we have +1, -1, +1, -1 on the bottom. So my EVs are +1 and -1. Oops. I cannot have -1 as one of my answers because that is an extraneous solution. So my only answer is x equals 4. And if you were to take the time and go back and plug this in, look what happens if I plug in a -1. At any point in the problem, if I plug in a -1, I get undefined. So that's why that can't work. Okay, let's keep going. All right, so, tricky. There's a negative sign there. Okay, this one's tricky too because getting the common denominator on this one's a little tricky. Okay, before I figure out what that is, I want to try to factor and pull out any GCFs. So I'm going to have x over x minus 1 minus 4x over, let's pull out the 2. That's going to be 2 times x minus 1. And let's pull out the 3. That's going to be 3 times x minus 1. Okay, so I've got an x minus 1, a 2 times x minus 1, and a 3 times x minus 1. So the common denominator is definitely x minus 1. They all have that. But then I have a 2 here and a 3 here. Well, if I'm adding 1/2 plus 1/3, 1/2 plus 1/3, what's the common denominator? You would just multiply these together and that would be 6. It's the same thing here. I just multiplied the 2 times the 3. So my common denominator in this problem is going to be the 2 times the 3 is going to be 6 times what the other thing they have in common, which is the x minus 1. Okay. All right. So let me rewrite this. X over x minus 1. I'm just rewriting this. What does this guy need? I've got an x minus 1. What's it missing? It needs a 6. So I need to multiply by 6 over 6. And then I have minus 4x over 2 times x minus 1. Okay. And what does this guy need? Okay. I have the 2x minus 1, but I need it to be a 6. So what is it missing? It needs a 3. So I'm going to multiply the top and bottom by 3. That's going to be equal to 3 over the 3 times x minus 1. In order to get this to be a 6, this needs a what? This needs a 2. So I'm going to multiply this guy by 2 over 2. Okay. So on top, 6 times 6 is 6x. Now, I know that my common denominator is 6 times x minus 1, so I'm just going to write that for the rest of the way. -4 times 3 is going to be minus 12 over, again, if you multiply all this out, that gives us our common denominator, 6 times x minus 1, equals 3 times 2, which is going to be, oh, excuse me, I'm sorry, 6 times x is 6x. I was about to say, I didn't see a variable anywhere, huh? That's just a good gut check. I started looking at it and I said, I didn't see a variable anywhere. Maybe I made a mistake somewhere. Those are the kinds of gut checks you guys need to be working through these problems because everybody's going to make mistakes. I'm going to make mistakes. You're going to make mistakes. But can you go back and check those mistakes by using your calculator and making those little mini gut checks as you're working through the problem? Makes all the difference in the world. Okay, 3 times 2 is 6. And that's over my common denominator of 6 times x minus 1. Okay, common denominator, bye. And I'm left with an equation on top. All right, so 6x, let's move the 12 to the other side. Let's add 12 to both sides. 6x is going to be equal to 18. And I am going to, oh, you know what? I just caught myself again. You guys are probably yelling. You probably are screaming at the video, Mr. Manice. This is a 4x. Okay, 4x times 3 is 12x. Okay, so check that. See? Look at me. Real world stuff right here. Okay, so let's subtract here. 6x minus 12x is negative 6x, and that's going to be equal to 6. And then I'm going to divide both sides by negative 6, and I get x is equal to negative 1. Okay, now, does that work? Do I have an EV of negative 1 anywhere? This would be an EV of 1 because I have to flip the sign, but no, I don't have an x plus 1 anywhere in the bottom. So that is good to go. -1 works. Okay, we can do it, guys. Keep pushing. Keep pushing. I'm telling you, if you can do this stuff, man, you can do anything. Anything. All right, so what is my common denominator? So let's rewrite this as 2 over... All right, so we need to... This is... Oh, goodness gracious, guys. This is a hard one. This is hard, but I'm telling you, you can do it. Push through. I've got to factor this, okay? So how do I factor before I even get started? Actually, you know what? I'm just going to come over here on a... Probably easier for me just to do this on a separate sheet of paper. Okay, so I'm just going to come over here and I'm going to factor the 2x squared minus 5x minus 3. So let's do that real quick. 2x minus 5x minus 3. Okay, so I got to do, if I'm trying to factor this, I got to do the rainbow thing. 2 times -3 gives me -6. What are the factors of -6 that add to -5? That's going to be -6 and 1. Okay, so I'm going to split my middle term. This is just factoring by grouping, factoring when a is not 1. So that's going to be 2x squared. I'll put the -6x over here. And I'll put the single x with the -3. Okay. All right, so now I can draw my curtain and I can group. I can pull out a 2x from here. That will leave me with x minus 3. There's nothing to do here. I can just pull out a 1. That's also going to leave me with the x minus 3. That's good news. They match. So one of my binomials, one of my factors is x minus 3. And the other factor is the leftover stuff on the outside, 2x plus 1. Okay, so let's go back to our problem. Don't you love math? Everything builds off of itself. So it's going to be 2 over this. Okay, so x minus 3 times 2x plus 1. Okay, and then that's going to be equal to 1 over x minus 1. Okay, this way. All right, so what is my common denominator? I've got an x minus 3, a 2x plus 1, and an x minus 1. Well, my common denominator is just all three of those. None of those have anything in common. So I just multiply that times that times that. So my common denominator is x minus 3 times 2x plus 1 times x minus 1. So we got a lot of stuff that needs a lot of things. Okay, so I'm going to rewrite this and say this guy needs a what? This guy needs an x minus 1, doesn't it? So I'm going to write this as, just trying to make sure I have enough room, 2 over x minus 3 times 2x plus 1. This guy needs an x minus 1 over x minus 1. And that equals 1 over x minus 1. What does this guy need? This guy needs the other two. So this guy needs an x minus 3 times 2x plus 1. Okay, we can do this. Stay with me. All right, so now when I distribute here, I'm multiplying 2 times that. When I distribute, okay, that's going to give me a 2x minus 2. Okay, 2 times x minus 1, 2x minus 2. And that's going to be equal to, now here I've got to FOIL this out. Okay, so once again, just for sake of room, I'm just going to come down here and just do this on a separate sheet of paper. X minus 3 times 2x plus 1. First is 2x squared. Outside is x. Inside is -6x. And last is minus 3. So that's 2x squared minus 5x minus 3. Okay, so that is what is going to be on the right-hand side of the equation when I FOIL this out. Okay, so I'm just going to stick this over there. So I've got 2x squared minus 5x minus 3. Guess what? I have a quadratic. Okay, how do I solve a quadratic? Set it equal to 0. I'm going to keep the 2x squared there. If I subtract 2x, if I move this to the other side, subtract 2x, that's going to be a minus 7x. And if I add 2 to both sides, add the 2 over here, -3 plus 2 is going to be minus 1, and now that's going to be set equal to 0. How do I solve this, Mr. Manise? That's a good question. If you try to do the rainbow thing, factoring when a is not 1, 2 times -1 is -2. There are no factors of -2 that add to 7. So guess what we got to do? Quadratic formula. You got it. Okay, so here we go. My a value is 2. My b is negative 7. Man, if you can get a problem like this right, then I should just give you a box of candy. Just box candy. Okay. B is negative 7. C is equal to negative 1. Okay. And again, for sake of space, I'm sorry if you guys don't have a whole lot of space on your sheet. Let's do the quadratic formula. Quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so my b is negative 7, but it's negative b, so it's negative 7 plus or minus the square root of negative 7 squared minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, which is 2. 2 times 2. Okay, so negative 7, that gives me 7. Plus or minus down here, just type all this in your calculator. It's probably the easiest thing to do. Parentheses, negative 7 squared minus 4 times 2 times negative 1. Okay, 57. Square root of 57, all over 2 times 2, which is 4. Can't do anything with that. I can't break down the square root of 57, so that is my answer. X is equal to, whatever this was, 7 plus or minus the square root of 57 all over 4. You get that right, come work for my company. I'm serious. Come work for my company. Because if you can do that, then I have all the trust and faith in you that you can do almost anything I ask you to do. Okay? That's why you learn all this advanced algebra, this hard stuff. Okay? To show a potential college employer you can do it. You're willing. You're able to do this stuff. Okay? While you're building all these process critical thinking skills. All right. So those are how you solve the rational equations. All right. So now let's look at these inequalities. Okay. So here we go. Solve the following rational inequalities. All right. Make sure your answers are on the number line or and in interval notation. Okay. Interval notation. All right. So the first step was, if you guys remember correctly, is to do what? Move everything where? Move everything to the left side. All right, so we need to subtract this. So I'm going to have 2 over x minus 3 over x plus 6. That's going to be less than 0. Always move it to the left. Don't move stuff to the right, because then you've got to flip the inequality sign, and that's just nasty. Okay, you'll confuse yourself. All right, I need to get a common denominator. So what's my common denominator? I just multiply those together. The common denominator is x times x plus 6. Okay, that means this guy needs a what? This guy needs an x plus 6. So I'll do x plus 6 over x plus 6 times 2 over x. And this guy needs a what? This guy just needs the x. So minus 3 over x plus 6 times x over x. That's going to be less than 0. Okay, let's go ahead and simplify this. When I distribute the 2 to both of those, that's going to give me 2x plus 12 minus 3 times x, which is 3x. I don't need parentheses there because I only have one term. Okay, you just need those parentheses when you have a binomial or subtracting a trinomial or something like that. All right, and that's going to be over my common denominator of the x times x plus 6. And now we need to, and this is less than 0, of course. Let's go ahead and simplify this. 2x minus 3x, that's going to be negative x plus 12 all over x times x plus 6 is less than 0. Okay, so that's step 1, moving to the left, and step 2, simplifying it down using your common denominator, get it down to a simplified term. Step 3 is to look at our CPs. Okay, to refresh your memory, CP is the critical point. And the critical points are the values in the numerator and denominator that give you a 0. So it's kind of like the excluded values in the bottom, but we're also adding quote-unquote excluded values in the top. Okay, so where does the top, what value in the top gives me a 0? Okay, well, you're literally going to set the numerator equal to 0. So negative x, I'll do this up here, negative x plus 12 equals 0. Add the x to the other side, and you get x is equal to 12. Okay, so one of my critical points, I'll write this here, CPs, one of my critical points is 12. All right, that's the numerator. Okay, the denominator, I've got this single x. Anytime you see just an x or an x squared by itself, that will always be a critical point of 0. And then this one, I just flipped a sign, negative 6. So those are my critical points. Now it's time to go to our trusting number line and I'm going to plot each of my critical points. And guys, these inequalities are hard because, well, all of these are hard because if you make a mistake, it's just kind of a cascading effect. But if you don't get any of this right, then of course you're not going to plot your CPs right. You're not going to be testing the right numbers, and you won't get the right interval notation. So make sure that you're not making mistakes with these critical points. Now I'm going to list these points in order from the smallest to the largest, starting with the -6. And then I have the 0, and then I have the 12. And it doesn't matter about the spacing. Now I'm going to test some points. Okay, I want to test, all right, test something less than -6. I'll use -7. Okay, you can use whatever you want. All right, so now when you plug this back in, guys, I don't really care what the number is. I'm just trying to figure out, is this inequality satisfied? Is it less than 0 or is it greater than 0? So I just care about the sign. I don't care about the actual numeric value. So when I plug these in, I just want to know, is the top positive or negative? Is the bottom positive or negative? So you got to be, and one reason this particular concept is hard is because it's so easy to mix up and make errors with your sign. So go slow. When you get to this point, guys, go slow. If you need a separate scratch sheet of paper, get out a separate scratch sheet of paper, okay? I'll do this on a scratch sheet of paper. Yeah, I know a lot of you guys can do this in your head, but I'm just telling you, if you make a lot of mistakes with signs, maybe you might need to do it this way. When I stick in a -7 into my inequality, I've got -x plus 12 over x times x plus 6. I'm going to break this down real slow, and then I'll kind of speed up for sake of time the rest of the video. Okay, if I stick in a -7, this already negative, so this is a -7 plus 12. Okay, that's going to make that a 7 plus 12. I don't care what the number is. Don't worry about 19. I don't care about that. I just want to know the numerator is positive. When I plug in a -7 to this part, -7 plus 6, that's going to give me a negative. Oops, rewrite this. That's going to give me a negative, and then I have times another negative. Okay, so on top I have positive, on the bottom I have negative times negative, which is a positive. So I have positive over positive, which overall is a positive. Does that satisfy this? Is a positive less than 0? No, it does not. So I'm going to put a little X mark right there, which means that I'm not going to shade anything to the left of -6 because no number less than -6 satisfies this inequality. -100, -1,000,000, none of those work. Okay. So now I want to go to something between -6 and 0. What do you want to test? What makes sense? -1, of course. I'll test -1. That sounds good. Okay, so now I'm going to go a little bit quicker. So if I stick in a -1, that's going to be a -1. That's a positive. Positive plus 12 is going to be a positive. So on top I have a positive. Okay. On the bottom, if I stick in a -1, -1 plus 6, that's going to be positive. So I have a positive over positive, but then I'm multiplying times -1 on the outside. That's going to give me a positive over a negative, which overall this whole thing is negative. Does that satisfy? Yes, negative is less than 0. So I can put a little check mark right there, which means I'm going to shade everything between 0 and -6. Okay. Once again, I can't emphasize this enough. If you need to slow down and work this out, please do that. Okay, let's check something between 0 and 12. Let's pick 3.58. Just kidding. Pick 1. Pick 1. Okay, pick easy numbers. If I stick in a 1, that's going to be -1 plus 12. That's positive. 1 plus 6, positive, times 1, positive. Positive over positive is positive. Nope, that's not less than 0. Put a little X right there. All right, so now let's look at something greater than 12. Let's pick 13. Okay, -13 plus 12 is a negative, so I've got a negative on top. And then I've got 13 plus 6, that's over a positive. And then times 13, that's times another positive. So I've got a negative over a positive, which is a negative. Does that satisfy? Yes, that's less than 0. So I'll shade everything greater than 12. Okay, that's not my answer. This says make sure your final answer is in interval notation. Okay, so you kind of think about it like domain. Where do I have x values? Where do I have shaded regions? I don't have any shaded. I got nothing. Nothing works until I get to -6. Now let's go back and refresh our memory on whether or not we have open or closed dots. If you do not have the equal bar, okay, there's no less than or equal to. If you don't have the equal bar, guys, everything is open. Okay, the only time I can have an a closed dot is when I have the equal bar, but also I can't include the excluded values on the bottom. So when I taught you guys how to do this, we listed out the critical points, 12, 0, -6, and then we went another step and said x cannot be equal to what? The CP's on the bottom. So x cannot be equal to 0, and it cannot be equal to -6. Now in this case it doesn't matter because I don't have an equal bar, so everything's open. It will matter on the next problem. All right, so I'm going to use the interval notation from -6 to 0, but I'm going to use parentheses because we have open dots. If it were a closed dot, that would be a bracket. Okay, there's a gap. All right, so there's our break union, and then I'm going to pick it back up at 12, and everything after 12 until infinity works. Okay, and there is my interval notation. Okay, let's keep going. All right, the next one here. So let's go ahead and everything's already moved to the left, so let's go ahead and break it down. Are there any factors of 3 that add to 4? Well, yes, there are. That's 3 and 1, so this is going to be x plus 1 times x plus 3. This is a difference of squares. This is going to factor as x plus 6 times x minus 6, and that's going to be greater than or equal to 0. All right, so what are my CPs? Okay, in the bottom, that's going to be 6 and -6. In the top, that's going to be -1 and -3. Okay, and x cannot be equal to 6 or -6 because those are the CPs that give us the 0 in the denominator. Those are our excluded values, okay, if you want to think about those, EVs. All right, so now let's plot our number line. All right, so we're starting with -6, and then we'll go -3, and then we'll go -1, and then we go +6. Make sure these are in the right order. All right, so let's test -7. All right, here we go. If I stick in a -7, that's going to give me a negative. That's going to give me a negative. So overall, that's positive. Stick in a -7, that's going to give me a negative. And then that's going to give me a negative. Negative times a negative is a positive. So a positive over a positive is a positive. Okay, it's tough, guys. I know. Tricky, tricky. Is a positive, is that greater than 0? Why, yes, it is. So we're going to shade everything to the left of -6. All right, -6 and -3, I don't know, let's go -4. All right, so if I stick in -4, that's going to be a negative times a negative. That's going to be a positive on top. All right, if I stick in a -4 down here, that's going to be a positive times a negative, which is a negative. And a positive over negative overall is negative. So that does not satisfy it. Okay, and again, don't fall into the trap of thinking it's going to be yes, no, yes, no, yes, no. It doesn't necessarily work like that. Most of the time it does, but not necessarily. All right, let's pick between -1 and -3. Let's pick -2. Our good buddy missed -2. -2, that's going to be negative, but that's going to be positive. So that's going to be a negative on top. Plug in -2, that's going to be positive, and a negative, that's going to be negative on the bottom. Negative over negative is positive. And yes, that works. So I'm going to shade that. -1 to 6, let's pick our friend 0. That's going to be positive, 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 negative. So that's going to be positive over negative, which is a negative. That doesn't work. And let's pick 7. If I plug in 7, that's positive, 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 positive. And yes, that works. So shade everything above 6. All right, so our notation is from -infinity. All right, let's go back to the dots. I have an equal bar. So I can put the equal bar on these two CPs, the -1 and the -3, but I cannot put the closed dot on the -6's because those are EVs in the denominator. So those have to be open circles. Okay, so it's going to be -infinity to -6 with parentheses because that's open. And then I'm going to pick it back. Oops, that's a bracket. That's a bracket. From -3 to -1, bracket. And then pick it back up with an open dot. 6 to infinity. Okay. Congratulations. We've just done the first page of this test review. Okay. Gosh, man, I might not be kidding when I said 2 hours. Okay. Let's keep going. All right. Oh, my goodness gracious, Mr. Manice, what you doing to us? I know, guys. You're not going to see this in your job. I was an engineer. I used a lot of this stuff. It doesn't look like this in your job. It looks like this. Okay, everything's in real life in the real world is word problems. Okay, you got to take the information and process it, analyze it, and use what you know and solve the problem. Okay, so here we go. A boat travels 50 miles downstream in this. I guess it could help if you could see it. the same time. Okay, hint, hint, there may be a problem like this on the test, just maybe. Okay, wink, wink. All right, so boat travels 50 miles downstream in the same amount of time that it takes to travel 20 miles upstream. Okay, the boat's speed in still water is 15 miles an hour. Find the speed of the current. Okay, so this is where we made our chart, but in this case, we really don't need a chart per se because I know that these things are happening at the same time. So my speed is 15 miles by myself, okay, but when I'm going against the current, isn't my speed the 15 miles an hour minus the current, okay? All right, so 15 minus c, okay, and that's going to be times. Okay, actually, let me back up for a second. Let me back up. It's probably easier to explain it this way. Okay, the boat is traveling 50 miles downstream. Okay, so I've got 50 miles downstream, okay, divided by my rate plus the current. Okay, that's going to be equal to 20 miles upstream when I'm going against the current. Okay, because remember, these are happening at the same exact time. So 50 miles is happening when I'm going my speed in still water with the current, because I'm going downstream. That's going to be the same thing as 20 miles when I'm going 15 miles an hour against the current. Okay. Now I'm going to set these equal to each other because these are happening at the same time. All right, so what's my common denominator? My common denominator is going to be 15 plus c times 15 minus c. Okay. So now, what does this guy need? This guy needs a 15 minus c over 15 minus c. Okay. This guy needs 15 plus c over 15 plus c. Okay. All right. So now we are ready to distribute here. So when I distribute, 50 times 15 is going to be 750 minus 50c. And I'm going to distribute here. That's going to be 20 times 15. That's going to be 300 plus 20c. And that's going to be over my common denominator, 15 minus c times 15 plus c. And guess what we get to do with the common denominators? They go away. And I'm left with an equation, 750 minus 50c equals 300 plus 20c. Okay, let's move the 50c to the other side and subtract 300 from both sides. Let's add 50c. So those cancel and those cancel. So I have 450 equals 20 plus 50 equals 70c. Let's divide both sides by 70. And we get the speed of the current is 6.4 miles per hour. Now, you got to stop and ask yourself, does that make sense? I'm sorry, guys. I'm sitting here writing. You couldn't even see it on the video. I'm sorry. So, yeah. So we solve this and we get 6.4 miles per hour. Okay, let's stop and ask ourselves, does this make sense? Do you buy that the speed of a river or a stream is 6 miles an hour? Yeah, sounds pretty reasonable to me. So always go back and ask yourself, does it make sense? Okay. All right, so number 12 says you want to add 80% of phosphoric acid, by the way, is what is in Coke, to a can of Coke, which is 330 mils, to decrease the pH and raise the acidity of your delicious beverage, increasing the burning sensation as it goes down your throat. Which, by the way, in case you were wondering, that's why it kind of burns when you drink Coke. It's a wonderful sensation, but it kind of burns. That's because there's acid in Coke, okay? It's phosphoric acid. It says if the concentration in a standard Coke is 2%, how many mils of 80% acid should you add to create a Coke solution that is 30% phosphoric acid, which will ultimately lead to your immediate admission into a local hospital? Just trying to be funny there. We've got to make a chart here, guys. Got to make a chart, just like I taught you in class. Okay, so here's what your chart's going to look like. Let's go ahead and draw it out here. Okay, so I'm going to have the amount of acid, and then I'm going to have total solution. Okay, and then I'm going to have the original, and then I'm going to have the added, and then I'm going to have the new. Okay, so the amount of acid, okay, so in the original can of Coke, what is the actual amount of acid that I have? Okay, it's going to be the amount of acid that's in the Coke, the 2%, times the 330 mils. Okay, so I'm going to write that. 2% is 0.02 times the 330. All right, and then the total solution of the original is 330 milliliters. All right, so the add, how much am I adding? I'm adding 80%. Okay, but how much am I adding? Okay, that's what I'm trying to find. It says how much acid are you going to add? So there's our x. Anytime we don't know something in math, we label it with a variable. What is the total solution that I'm adding? Well, again, that's the unknown. That's what I'm trying to find, x. When I get done, how much acid will be in there? It will be the original plus whatever I added. So it's going to be the 0.02 times 330, whatever that is, plus the 0.8x. Okay. What is the total solution? It's going to be the original plus what I add. So that's just going to be x plus 330. Okay, so now I'm ready to set up an equation. It says when we get done, I'm trying to make a 30% acid solution. Okay, so when I get done, I want to have 30%. Another way to write that is 30 over 100, or 3 over 10, whichever you prefer. All right, I'll just use 100 because that's what we're used to thinking about with percentage. That percent, when I get done, that's got to be equal to what I am, the new solution here, okay? So the amount of acid, okay, that's going to be the new solution, so that's going to be what's on top. That's going to be the 0.02 times the 330 mils plus the 0.8x. I'm just copying this up here in the top, okay? And that's going to be over my total solution. Okay, my total new solution when I get done is going to be the x plus 330. Okay, so let me just recap that once again. The final percentage of acid is going to be 30%. 3 over 10, 30 over 100. Okay, that's going to be the acid in the physical amount of acid in the new solution divided by the total new solution, which is the x plus 330. Okay, now here's where we learned what we learned. Now it comes in the rational expressions. How do we solve this equation? Okay, what's my common denominator? Right? My common denominator, if I multiply that times that, my common denominator is going to be 100 times the x plus 330. Okay? So what does this guy need? This guy needs the x plus 330. So it's going to be 30 over 100 times the x plus 330 over x plus 330. Okay? And that's going to be equal to, what does this guy need? This guy needs the 100. So let me go ahead and multiply this out. So if you multiply 0.02 times 330, that comes out to be 6.6. So 6.6 plus the 0.8x over the x plus 330. And we said this guy needs the what? This guy needs the 100. So we need to multiply this by 100 over 100. Okay, so now we distribute. That's going to give me 30x plus 30 times 330 is 9,900, 9,900 over the common denominator. Okay, that's going to be equal to, when I multiply this times 100 times 6.6, that's going to give me 660. 0.8 times 100, 0.8x, that's going to give me 80x. And this is over my common denominator. Okay, if you get lost here, guys, pause the video and back up. Watch as many times as you need. We've got our common denominator here. Bye-bye. See you later. And now I'm just left with an equation on top. So I've got 30x plus 9,900 equals 660 plus 80x. Okay, so if I move the 30x to the side, I have 50x is equal to, if I subtract 660 from both sides, that gives me 9240. Divide both sides by 50, and you get x is about 185 milliliters. Okay, does that make sense? Yeah, I buy that. We started with 330. I'm going to have to add a good bit of it to a good bit of the 80% solution to get it from a 2% all the way up to 30. So yeah, I buy that. I'll have to add about half of it or so, more than half of it. So that makes sense to me. Okay, so the next one here is one of the easier ones. All right, so anytime you're trying to work together, two people or two entities working together, trying to figure out how long it's going to take, we have this equation here: 1 over a plus 1 over b equals 1 over t. All right, and so it takes the student A 25 minutes to complete his homework, takes student B 20 minutes for her to complete her homework on the same assignment. If they work together on the assignment and share answers, which is called cheating, how long will it take them to finish the assignment? Okay, so the first one is going to be 1 over 25 minutes. The second one is going to be 1 over 20 minutes, and that's going to be equal to 1 over t. Okay, what's the common denominator? Yeah, you can multiply these two numbers together, but is there a lower common denominator? 100. Okay, so 25 goes into 100 and 20 goes into 100. So this needs a what? This needs a 4 over 4, and this needs a what? That needs a 5 over 5. So I have 4 over 100. Oh, excuse me, common denominator is 100t. Excuse me, you got to multiply all these together. 25 times 20 times t. So this guy needs a 4t over 4t, this guy needs a 5t over 5t, and this guy needs a what? This already has the t, so this guy just needs 100 over 100. Okay, so when I multiply across the top here, that's going to be 4t. Multiply across the top, it's going to be 5t over 100, and that's just going to be 100 over 100t. Okay, so we've got our common denominator. Those go away. So I have 4t plus 5t. I have 9t equals 100. Divide both sides by 9. And my time is 11.1 minutes. Okay. Do you buy that? One person 25 minutes, two people 20 minutes. So if they're working together, it should be about half that, maybe a little bit less than half of that. So yeah, 11.11 minutes sounds reasonable to me. All right, number 14 here, a debt of $420 is shared equally by a group of friends. When 5 of the friends decide not to pay, which immediately expunges their title of friend, the share of the other friends goes up by $25. How many of these so-called friends, whatever, not really friends, were originally in the group? Okay, the hardest part of this question, guys, is how do you set this thing up? Okay. And this, again, these are critical thinking skills that you're training your brain to go through. All right, so you got to kind of slow down and think about it here. We've got $420. Maybe we went to a concert, dinner, movie, whatever. It's being split between some friends. Okay, so I got $420. I'm going to let X be friends. $420 divided by X friends. Okay, so if we had 10 friends, everybody's spending $42. Okay. When the friends go away, when our so-called friends, 5 of them leave, then this is what we're paying, 420 divided by X. When they leave, there's going to be what we're paying is going to increase by 25. When math increase means add. So our whatever we pay, this guy right here, that's what we pay, is going to increase by 25. Okay, that's got to be equal to the original debt, 420, but it's not divided by X amount of friends anymore. It's divided by what? We've lost 5 friends, so it's got to be divided by X minus 5 friends. So let's think about that. The $420 debt divided by the total friends minus these 5 losers, that's going to be equal to what we were going to pay with the increase of $25. Okay, so now how do I solve this? My common denominator is X times X minus 5. Of course, this is just over 1. So what does this guy need? 420 over X. This guy needs a what? This guy needs an X minus 5. This guy needs a what? This guy needs everything. This guy needs an X times an X minus 5. Sorry. X minus 5 over X times X minus 5. And that equals 420 over X minus 5. What does this guy need? This guy's missing an X, so he needs X. Okay, so now let's distribute. X times 420, that's 420X. Negative 5 times 420 is negative 2100. All right, now here, this is a little tricky. I would go ahead and multiply the X times X minus 5. X times X minus 5 is X squared minus 5. And then I would distribute the 25 to the X squared minus 5. That's going to be plus 25X squared. 25 times negative 5 is minus 125X. And then here, just multiply 420 times x. And all of this is over our common denominator of x times x minus 5. And we get to say bye-bye to our common denominators. Okay, so now I've got a 420x on the left, a 420x on the right. See you later. I've got the 25x squared minus 125x minus 2100, and that's equal to what? I'm just left with a 0. All right, so here we go. We got a quadratic set equal to 0. Yeah, you can do quadratic forming if you want, but they're all divisible by what? Let's pull out the GCF. I want to see if I can pull out a GCF. That's going to leave me with x squared minus 5x. Negative 2100 divided by 25 is minus 84. Are there any factors of negative 84 that add to negative 5? Yes, there are, and you could use your calculator if you wanted to. I'll just refresh your memory real quick on this trick. I'll just type in 84 divided by x and go second table, and I'm looking for a combination of numbers that will somehow get me to a negative 5. Okay, that are basically 5 apart from each other. Okay, there you go, 7 and 12. Right there, 7, 12. All right, so this is going to factor as, it's got to be negative 84, and they've got to add to negative 5, so the bigger one's got to be negative, so that's going to be x minus 12, x plus 7. Flippy flip, so x is equal to positive 12 and negative 7. But we're talking about these so-called friends. I can't have negative 7 friends. So the answer is 12 friends, and we lost 5 of them, and our price increased by 25 bucks. Whew, man, I'm getting tired. I know you guys, you've got to push. You can do it. You've got to push. I believe in you so much. You can do it. You can do it. Just remember why you're pushing. Okay, so now we're to the graphing rational expressions that we've been working on for about 5 years, okay? Name the vertical, horizontal, slant asymptotes as well as any holes that we have. Okay, here we go. Vertical asymptote, okay? And by the way, this should be a 3. That should be a 2x to the third on top there. Vertical asymptote is your excluded values. Where do I have zeros? What values give me 0 in the denominator? Well, if I set x squared plus 9 equal to 0, I get x squared equals negative 9. You can't take the square root of a negative. So I don't have any vertical asymptotes, okay? All right, so that's if you have imaginary solutions, then it's just none. All right, horizontal asymptote is your top heavy, bottom heavy. Okay, what are we? We got a 3 in the top and a 2 on the bottom, so we're top heavy by 1. So when you're top heavy, you don't have a horizontal asymptote. Top heavy. Again, you're going to have to go back and study your notes on this stuff if you can't remember these. All right, slant asymptote, when we are top heavy by 1, which we are, then we have to use long or synthetic division, okay? I can't use synthetic division because I'm dividing by, you have to divide by something like x plus 2 or x minus 3. It has to be linear, and you can't have a coefficient in front of the x, okay? So I'm going to have to use long division, so I'm going to divide x squared plus 9. I'm going to divide that into the numerator, 2x to the third. Okay, I don't care about the 9. How many times does x squared go into 2x to the third? Or in other words, 2x cubed divided by x squared equals what? Okay, that's going to be 2x. Okay, so on top I'll have a 2x. You got to go back and multiply. 2x times x squared is our 2x to the third, but then I taught you to do what? Change the sign. And then 2x times 9 is 18x, but we change the sign. Those cancel, and I'm left with negative 18x. And then we got to keep going. How many times does x squared go into negative 18x? It doesn't, because that coefficient is higher than that one, so you can't do anything else. We're done. But my slant asymptote is not 2x. Remember, it's the equation of a line. It's y equals 2x. This is just a regular line with a slope of 2. Okay. Holes. Holes are when you have a factor in the top and the bottom that cancel. So if I have x plus 3 times x plus 2 over x plus 2, the x plus 2's would cancel, and I would have a hole, and you got to flip that sign. I would have a hole at x equals negative 2. But I don't have that here. Nothing cancels, so we're good. I don't have any holes. None. Okay, vertical asymptote. Look at your denominator. If I set that equal to 0, 10x is equal to negative 1. Divide both sides by 10. I have a vertical asymptote at negative 1/10, but please, I know it's so hard. I know it's hard. Do not write negative 1/10 because remember it's the equation of a line. Okay, it's the equation of a vertical line. All right, so it's going to be x equals negative 1/10. Okay, horizontal asymptote. Are we top heavy or bottom heavy? We're neither. We have a 1 and a 1. So when it's neither, you look at the a divided by the b. You look at the coefficients. 5 divided by 10 is 1/2. Don't write 1/2. Horizontal, if vertical is x equals and horizontal is y equals. Y equals 1/2. Okay. Slant asymptote, well, you can't have a horizontal and a slant asymptote at the same time. So if you got a blank in one, if you got an answer in one, then the other one's none. And remember, you can only have a slant asymptote when you're top heavy by 1, which we don't have. Does anything cancel on the top and the bottom? No, so we don't have any holes. Okay, 17. I need to factor the bottom here. Okay, so I got 3x squared plus 7x minus 20. Okay, let's do the rainbow thing. 3 times negative 20 is negative 60. Are there any factors of negative 60 that break down, that add to 7? 12 and 5 again. They got to multiply to be negative 60 and add a positive 12. So since the middle term is positive, the bigger one has to be positive. So that's going to be a positive 12 and a negative 5. So let's break that down into 3x squared plus 12x minus 5x minus 20. Let's draw our curtain. Let's pull out a 3x, x plus 4. Let's pull out a negative 5, x plus 4. So we have x plus 4 times 3x minus 5. Okay. All right, so if I solve this, on this one I can just flip the sign. So x is equal to negative 4. Now this one, move the 5 to the other side. So 3x equals 5 divided by 3. You get x is equal to 5/3. Okay. So I have now solved the bottom, and I had to do that to find the vertical asymptotes. Okay, remember, it's the equation of a line. It's x equals negative 4 and x equals 5/3. Yes, I need to see two different equations. Please don't just write x equals negative 4 comma 5/3. It's two separate equations. Horizontal asymptote is top heavy, bottom heavy. We are bottom heavy, so when we're bottom heavy, it's y equals 0 every single time. We don't have a slant asymptote because we're not top heavy by 1, and nothing cancels, so we have no hole. Are you ready to rumble? Hardest stuff ever. You can do it. I know you can do it because you guys are brilliant. Okay, so for the rational functions below, provide all million of these things. Okay, it's a lot of stuff. All right, on the test, I will give you blanks so you won't have to write all this stuff out. Okay. All right, so let's start with our vertical asymptotes. First thing I want to do is I want to simplify all this stuff. On the top, I can pull out a GCF. So I'm going to say f of x, or I'll just change it to y equals, the same thing. Let's pull out a negative 3. That's going to leave me with x plus 1. That's the difference of squares. That would be x plus 3, x minus 3. Okay, I really can't go any further unless I simplify my rational expression so I can see where the zeros are. All right, let's go ahead and start. Number 1, vertical asymptote, VA. That's in the bottom. Where do I have zeros in the bottom? Negative 3 and 3, but they are equations of lines. So x equals 3, x equals negative 3. Horizontal asymptote. Okay, are we top heavy or bottom heavy? We're bottom heavy, so that's going to be y equals 0. Slant asymptote, I don't have one because we're not top heavy by 1. Holes, do I have any holes anywhere? Is there anything that cancels in the top and the bottom? Nope, so I don't have any holes. Okay, x-intercept. Okay, how do I find the x-intercept? It's the reverse of what you think it would be. For the x-intercept, you stick in a 0 for y. Okay, if I stick in a 0, if you guys remember how I showed you, the denominator just goes away because if I multiply both sides by that, it just goes away. So basically, when you find the x-intercept, guys, all you have to do is set the numerator equal to 0. Okay. Now, you can literally set this part equal to 0, or if you've already factored it, which is why another reason why I want to factor stuff, just look at this. All I have to do is just flip that sign. So x is equal to negative 1, but remember it's an x-intercept. An x-intercept is a point on this grid. So it's going to be a number, comma 0 for every x-intercept. So that's going to be negative 1, comma 0. Okay. All right, is there anything else? No, that's it. That's the only x-intercept I have because I only have one number that gives me a 0 in the numerator. Okay. All right, what about y-intercept? Okay, instead of plugging a 0 for y, for the y-intercept, you're going to plug in a 0 for x. Now, in this case, it probably is easier just to go back over here and stick in a 0 here. If I stick in a 0 here, that goes away. If I stick in a 0 there, that goes away. I'm left with -3 over -9, which is 1/2. Or remember, it's a y-intercept. X-intercept is number comma 0. Y-intercept is 0 comma number. So this is going to be 0 comma 1/2. Let's go ahead and plot these points. -1 comma 0, that's my x-intercept. 0, 1/2, that's my y-intercept. Okay. All right, let's go ahead and plot our vertical asymptotes. X equals 3, x equals -3. Dotted line here for our asymptotes. Okay, and then +3. Okay. So now I pretty much have everything that I need to graph this. So now you can use your graphing calculator to get a general sketch of what this looks like. So let's type in our original rational function, parentheses -3x minus 3, close the parentheses, divided by, let's see, x squared minus 9, close the parentheses. Let's graph that. Looks like my window's out of range here, so I'm going to go zoom 6, zoom standard window. There we go. Okay, there's an asymptote, and there's the other asymptote. Okay, so now I've got what I need. All right, I know that on the left-hand side of my graph, that the graph is doing this. Okay, so I'm going to draw just kind of a general. Oh, I forgot to draw the horizontal asymptote. The horizontal asymptote y equals 0. That's basically just the what? That's just your x-axis. Okay. All right, so my graph is going to do this in this region. Something like this, and it doesn't have to be perfect, guys. Just a general sketch. And then for the middle part, it's doing this number. I'm making money, and then kind of zigzags and making some more money. But I've got to go through these points, and I do need to see these x and y intercepts plotted on your graph. So it's going to come up, it's going to go through the x-intercept and the y-intercept, and then keep going, keep making money. And then the second part, the third part of the graph, we're going up to the horizontal asymptote. It's going to look something like this. Okay, so that's a pretty good sketch. All right, next thing they want, we've got all the asymptotes, we've got the holes, we've got the intercepts. They want domain and range. Okay, no problem. Okay, where do I have x values? The only time I care about y values is the what? That's the range. Domain, intervals of increase, intervals of decrease, all that stuff, we're looking at x values. All right, so I have x values from -infinity until what? Until I hit this vertical asymptote. So -infinity to -3. There's no parentheses on. The only time you can have a bracket on anything is in the range, and only when you have those relative max and mins. Okay, so if you're not sure, don't. It's always parentheses except for range. Parentheses, break, and then I will continue. I'll pick it back up. I will continue to have x values between the two asymptotes, so between -3 and 3. Break. And then we'll continue to have x values from 3 forever, from 3 to infinity. Okay, range. Tricky, tricky, tricky. Karate Kid, paint the fence, right? Paint the fence, sweep up, okay? I have y values from -infinity, and I will continue to have y values until where? And a lot of you guys will say, I'll have y values until I hit this horizontal asymptote at y equals 0. And normally you would be correct. However, notice that the middle part of the graph cuts through the x-axis. It cuts through that horizontal asymptote. And you can cross over horizontal asymptotes with these rational expressions. So in that case, I have y values everywhere based on this middle part. So this is just -infinity to infinity. Okay. Now remember, if you have holes, those will affect your domain and range, okay? So keep that in mind. All right, what about my intervals of increase and decrease? Okay, remember the trick that I taught you in class. If you're making money everywhere, or you're losing money everywhere, if your graph is always going up, then your interval of increase will be the same as the domain. If you're losing money everywhere, then your interval of decrease will be the same as the domain. So what's happening here? My company's making money, woohoo! My company's making money. Woohoo! My company's making money. Woohoo! Okay, we're making money everywhere. So our interval of increase is going to be the same exact thing as the domain. From negative infinity to negative 3, we're making money. From negative 3 to 3, we're making money. And from 3 until the end of the time, we're making money. That's the kind of company I want to work for. If I'm making money everywhere, where am I losing money? Nowhere. I have no interval of decrease. Okay. All right. Last thing here is our end behaviors. So as x is going to infinity and as x is going to negative infinity, what's going on? Okay, as my x value, see these little numbers? As these numbers get bigger and bigger and bigger and bigger, my y values are going up, 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 but where are they going to? Most of the time in the end behavior, we say, oh, it's going to infinity forever, or it's going down, but this one goes up and it never gets to the x-axis. It gets close, but it never touches it. So we are approaching the horizontal asymptote, which is 0. Y is approaching 0. On the other side, as the x values get less and less and less, my y values are approaching the same horizontal asymptote. They're approaching 0. Okay. All right, we can do it, guys. Come on. Come on. I know you can do it. Stay with me. Feels good. I love this stuff. I love it. Okay, here we go. Number 19. All right, let's start off with our vertical asymptotes. Okay, VA. Oh, actually, let me back up. We need to see if we can factor this stuff first. All right, on top, we need to pull out a GCF of 4. On the bottom, what can I factor out? Ooh, they all have an x. I can factor out an x. That will leave me with x squared plus 5x plus 6. And how does that factor? Factors of 6 add to 5. That's going to be x plus 3, x plus 2. Hello. X plus 3 on the bottom, x plus 3 on top. Ding, ding, where's my bell? Ding, 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 ding. Ladies and gentlemen, we have a hole. Houston, we have a hole, okay? And so this is going to affect a lot of different stuff, okay? So keep that in mind as we go. Vertical asymptote, that is where we have zeros in the denominator. I've got a single x, so that's going to be one of my vertical asymptotes. So remember, it's the equation of a line, x equals 0. That's going to be an asymptote. All right. So, excuse me. I almost caught myself. If you have a hole, there is no horizontal or vertical asymptote at the hole. It's just kind of the little silly analogy I gave in class where you're jumping over a pit. Okay. The graph is going along, and then boom, there's a pit. You jump over it, and the graph keeps going. Okay. There's a literal hole right in the graph. Okay. That is not an asymptote. It's not something that we're approaching. It's just a literal gap in the graph. So I only have a vertical asymptote at the x, 0, and at this guy, the negative 2. Okay, so please don't get confused on that. Okay. Horizontal asymptote, top heavy or bottom heavy? Okay, we're bottom heavy, so that's y equals 0. And what is our slant asymptote? We don't have one because we're not top heavy by 1. Hole, where do we have a hole? Okay, so these guys cancel, all right? So wherever they cancel, you flip the sign. So I have a hole at negative 3. So you can say x is equal to negative 3, okay? Now, for purposes of finding out this exact spot, because that is going to affect our domain and range, intervals increase and decrease, the way that you're going to find the y coordinate, because the hole is a coordinate point, something comma something. To find the y coordinate of the hole, what you're going to do is after you cancel this stuff out, I'm going to be left with a simplified function or expression. I'll be left with 4 over x times x plus 2, right? That's after I cancel those. What you're going to do is you're going to take this guy and you're going to substitute it in for x into the new equation. Okay, so I'm going to have 4 over negative 3 times negative 3 plus 2. That's 4 over negative 3 times negative 1, which is 4 over positive 3, which is 1.3 bar or 1.3 repeating. Okay, so I'm fine however you want to list this as the whole. If you want to write x equals negative 3, that's fine. Or I'm perfectly fine with you saying that the whole is negative 3, comma, the y coordinate of the whole, which is 1.3 bar. Okay. All right, so that's the whole. Back up the video and watch that again if you need to. All right, x-intercept. Okay, x-intercept is where I'm setting the numerator equal to 0. Okay, so I've got 4 times x plus 3. So I would flip that sign and I would say I would have an x-intercept at -3, 0, right? Set the numerator equals 0. Ugh, tricky, tricky. Look at this. That's where a hole is, though, okay? So I can't have an x-intercept at the hole. So I'm going to say there is no x-intercept. And if you look at the graph, you'll see that. It never crosses the x-axis. I can't have x-intercept at a hole. Can't have an x-intercept at a hole. Y-intercept, what do I do? Okay, for the y-intercept, I'm going to stick in a 0 everywhere I see an x. Okay, so if I stick in a 0 everywhere I see an x, if I stick in a 0 here, goes away, goes away, goes away. Whoops, I have 0 in the denominator. Can't have that. So I don't have a y-intercept either, okay, because our function is undefined at 0. That is our vertical asymptote. Okay, it's not defined on the y-axis. So how can you have a y-intercept when there's nothing on the y-axis? Okay, I do have. If you were to graph this, guys, I do want to show you this first. Let's go ahead and graph this thing. Parentheses 4x plus 12 divided by parentheses x raised to the third plus 5x squared plus 6x parentheses. All right, if you graph that, there's our asymptote at -2. There's our vertical asymptote at 0, which is the y-axis. Then I have this little piece down here. I do need to find the coordinates of that little relative max. So we're going to get Mr. Spidey, second calc. I'll do that again, second calc. I want that maximum. Okay, so where's my cursor? All right, there he is. Move your cursor until you see Mr. Spidey. Move him to the left of that spot. That's good. Enter. Move it to the right. Enter. Yes, I want you to guess. And we have a relative maximum at -1, -4. That's just kind of a glitch right there. Okay, so I'm going to say relative max is at -1, 4. Okay, that is also going to affect our range. Okay, domain. All right, now before I get this, I've got enough to plot everything that we need. So let's go back and plot our stuff. I've got a vertical asymptote at the 0, which is the y-axis. Have a horizontal asymptote at y equals 0, that's the x-axis. Okay, and then I have no slant asymptote. I've got a hole at -3, 1.3. -3, 1 and a little bit more. So right there, I have a literal hole in the graph. X-intercept, y-intercept, we don't have any, but I've got a relative max at -1, 4. So -1. Oh, I'm sorry. That's -4. Yep, -4. -4. So -1, -4. Okay. Relative max. All right, let's look at our graph and get an idea of what's going on. So I'm going to draw my graph. I'm going to get to the hole. All right, stop. Jump over the pitfall from Atari, 1948. I don't know. Who knows when Atari was made. All right, then I've got, oh my goodness. I forgot about this one. I forgot about the other vertical asymptote. I'm sorry, guys. So I have a horizontal asymptote at -2. I just caught myself. Okay, sorry about that. So the hole goes up, and then the graph does this. Okay. All right, so there's my vertical asymptote at -2. And then in between the -2 and the 0, we've got this little piece of the graph that comes up and does this little thing. Okay. And then we have the rest. And then we have the rest of the graph that comes down like this. Okay, so there's our graph. All right, so our domain, where do we have x values? Okay, tricky, tricky, guys, tricky, tricky. Wink, wink, okay? All right, so I've got x values from -infinity, and then I have to stop here at the hole. I don't have any x values at that hole. I don't have an asymptote. I don't have an x value. I got nothing. So there's a break at an x value of -3, okay? That's the hole. There's no parentheses. There's no bracket there. That's parentheses. And then I will continue to have x values in this little piece of the graph from -3 to the next vertical asymptote. So from -3 to -2, I've got x values. And then I will continue to have, then we jump down here, and I will continue to have x values from -3, from -2, okay, -2 until I hit this vertical asymptote, which is at an x value of x value of 0, okay, union, and then I'll pick it up from 0 from the y-axis. I will continue to have x values everywhere. So that would be from 0 to infinity, okay. So let me just show this to you right here. This is what I have on my posted answer key. That -3 is the whole. That -3 is the whole. This -2 and that -2 is our asymptote, okay. And then that 0 and that 0 is the asymptote. Okay, so our x values are, things are happening around that whole, that asymptote, and that asymptote. Okay. All right, range. Okay, I paint the fence, Karate Kid. I have y values from -infinity all the way up to that guy. Okay, so -infinity, but that is the y coordinate. This is the only time where I care about the y values. I need the y coordinate of, excuse me, I need the y coordinate of the relative max. Okay, so that spot right there, that's our relative max. Okay, that y value is sitting there at -4. Okay, so my range goes from -infinity to -4. Okay, and then there's nothing going on here. Okay, there's a big gap. This is a big void. All right, I don't have any more y values until I hit a y of 0. Okay, so there is a, and by the way, that's a bracket on the -4 because we are including that value. So there's a bracket, and then there's a break. All right, and then we don't pick up the y values again until we hit 0. So that's going to be 0. And here's where it gets really tricky, guys, really tricky. You might say, well, the range, man, there's a break right here, right? There's a break at the 1.3. However, if you look to the right, to its twin brother, there is a y value on the other side. Okay, so yeah, it skips there, it jumps over the pit there, but it doesn't jump over the pit here. So I will have y values everywhere in here. Okay, so I'm going to pick it back up at 0 all the way to infinity. Okay, it's a tough one, guys. That's a tough one. Okay, intervals of increase and decrease. Okay, so our interval of increase, where am I making money? Okay, now again, I'm looking at my x values. I'm making money from -infinity, I'm making money, and then I stop at the whole. Okay, so from -infinity to the x coordinate of the whole, because I'm looking at x values for intervals of increase and decrease, from -infinity to -3. Okay, then there's a break. I will continue to have, I'm continuing to make money from -3 to that vertical asymptote, -3 to -2. And then I'm also making money when I get to the vertical asymptote. I jump back down here, and then I'm making money from the vertical asymptote to that relative max. All right, so that's going to be, again, it's only x values. I'm only looking at those numbers. Okay, does it look like my pen's wiggling? Those numbers. All right, so from -2 to the x coordinate of the relative max. Okay, so that's going to be -2 to the x coordinate, which is -1. Okay, so let me write this down for you. This is the whole. That -3 and that -3 is the whole. This -2 and that -2 is the asymptote. Okay, and then that -1 is the x coordinate of the max. Okay, -3 is the whole. -2 is asymptote, and that -1 is the x coordinate of the maximum. That spot right there. Okay. All right, I know, guys, I know, I'm sorry, this is tough stuff. Interval of decrease, okay, where am I losing? Where's my company losing money? I'm losing money from this part, from the relative max. I'm losing money, hit that asymptote, and I will continue to lose money, okay? All right, so that's going to be from the x coordinate of the relative max, from -1 to this vertical asymptote, which is 0. All these are parentheses, union, and then from the vertical asymptote to forever, I will continue to lose money. Okay, so that's going to be from 0 to infinity. All right, my end behaviors. As x goes to infinity, Okay, as the x values get bigger and bigger and bigger and bigger, my y's are approaching the horizontal asymptote. They're approaching 0. Y is approaching 0. As x goes to negative infinity, okay, it's the same thing. We're approaching 0. X goes to infinity, approaching 0. Y goes to negative infinity, we're still approaching 0. You can do it, guys. You can do it. Last one here. Last one. Okay, so let's see if we can break this down. So on the top, I can factor out a GCF of x. That's going to be x minus 1. And I'm just left with x plus 1. Okay, fair enough. Our vertical asymptote. Okay, that's when x is 0 in the denominator. That's easy. That's just going to be x equals negative 1. Horizontal, top heavy or bottom heavy? We're top heavy by 1. Okay, so when I'm top heavy by 1, when I'm top heavy, I don't have a horizontal asymptote. I do have a slant asymptote on this one, and this is where, thank goodness, we get to use synthetic division, because that's linear with a coefficient of 1. So I'll flip that sign, so I've got negative 1. Do I need a filler? Yes, I do, because I have 1, negative 1. I don't have a constant, so this is 1, negative 1, and then 0. Bring down the 1, that's negative 1, that's negative 2, that's positive 2, bring down the 2, don't care about the remainder. So that's going to be y equals x minus 2. That's our slant asymptote, y equals x minus 2. And then holes. Do we have any holes? Does anything cancel in the top and the bottom? Thank you, sweet Lord, no. No holes, no holes. Okay, x-intercept. X-intercept is where you just set the numerator equal to 0. Okay, so, but this case I have two places. Okay, I can set that x equal to 0, and that's just 0. So that's going to be the origin, 0, 0. Okay, and then if I flip that sign, that's going to be a 1, and that's going to be 1, 0 for the x-intercept. Okay, and y-intercept is where everywhere we see an x, we stick in a 0. So 0 minus 0 is 0. And then 0 over 1, 0 over anything is just 0, unless it's 0 over 0. Okay, so the y-intercept is going to be 0, so that's also going to be the origin. So a lot of stuff happening at the origin. All right, and now let's go ahead and graph this and see if we got any relative max or mins. Okay, x squared minus x divided by x plus 1. Okay, let's graph that bad boy. Okay, yep, so there's a relative max and there's a relative min. Okay, you absolutely, guys, will have one like this on the test, so make sure you know how to do this last one. Let's go find those points. Let's go second calc, find the max. Or actually, okay, let's just go ahead and find the min. That's fine. Okay, go to the left, enter, go to the right. That's good. Press enter. Now I did see a few students that got these confused. They were thinking that this was a maximum because it's higher than that one. Okay, this is still a minimum. The graph is coming down and making some minimum low point and then going back up. So this is a relative minimum. Okay, so the coordinates are 0.4, comma negative 0.2. So relative min, and you can just round to 1 decimal place is fine. Negative 0.2. And let's find the relative max. Okay, second calc, max. Move Mr. Spidey over. You got to give me over to the other spider web, so you got to keep pressing over. There he is, and he'll just jump to the other spider web. Okay, that's good. Press enter. Go to the right. That's good. Press enter. Press enter again. There's our relative max. Negative 2.4, negative 5.8. Okay. Now I've got everything I need to plot my graph. Vertical asymptote at negative 1. Okay. Slant asymptote at y equals x minus 2. Now if you want to plot, I don't need to see this, guys. If you want to plot it, knock yourself out. I'll go to a y-intercept of negative 2, and then I've got a slope of 1. You want to draw that? Cool. Okay. Don't have any holes, and then I need to plot my relative min. That's 0.4, negative 0.2. So that's over a little less than half, and then down just a little bit, somewhere right in there. And then my relative max is about negative 2.5, almost negative 6. So there's about 2.5, negative 6, somewhere about in there. Alright, so now I just need to look at my graph and kind of get a general idea. I do have my X and Y intercepts are sitting there at the origin, so you do need to plot that. You need to make sure your graph goes through both of those spots. So I'm coming down, go through the origin, hit that relative min, and then we're heading up, hugging that asymptote. And then here I'm hugging the asymptote, go through that relative max, and then come down, hug the asymptote. Okay, there we go. That's a good graph. And so now we're ready for the home stretch. Domain, where do I have x values? I have x values everywhere from negative infinity until I hit what? Until I hit that vertical asymptote. So negative infinity to negative 1, okay, and then union, and then I'll continue to have x values from negative 1 forever. Okay, range, now here's where the max and mins, the relative max and mins come into play. Paint the fence. I have y values from negative infinity up to the y coordinate of that relative max. So from negative infinity up to the y coordinate of the relative max, negative 5 point. Is there a bracket on that? You betcha. That's the only place we can have a bracket. Union, and then I'll pick up y values again until I hit that y coordinate of the relative min. Again, we only care about the y values. So that's bracket, negative 0.2. all the way up, and I'll continue to have y values forever. Okay. Intervals of increase and decrease. Okay. Where's my company making money? Okay, we're making money from negative infinity. Now we care about the x value. So I'm making money from negative infinity until I hit the x coordinate of that relative max. Okay, the x coordinate. That's going to be the negative 2.4. That's all parentheses. Anytime you're using x values, it's all parentheses. All right, and now there's a break. And then from here, after that spot, now I'm losing money. So that's interval decrease. And then from here, I'm losing money, losing, until I get to the x coordinate of the relative min. So starting at the x coordinate of that guy, so starting at 0.4, I will continue to make money forever. Okay, so 0.4 to infinity. Okay, where am I losing money? From the x coordinate of the relative max, so from the negative 2.4, I'm losing money until I hit the vertical asymptotes. I know it's tough, guys. Vertical asymptote, which is at negative 1, break, and then picking right up after the vertical asymptote at negative 1, I'll continue to lose money until I hit the x coordinate of that relative min, which is 0.4. Okay. All right. We're almost there. Almost there, guys. Okay. In behaviors, as x goes to infinity, as these x values get bigger and bigger and bigger, these y values go on forever and ever and ever and ever. They're headed towards infinity. And as my x values get smaller and smaller and smaller, my y values are going down, 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 down to infinity. Negative infinity. Yes. Yes. We did it. I can't believe it. This video is 1 hour and 42 minutes long. I was absolutely, I'm not kidding you guys, I actually was kidding at the beginning of this video, joking that it might be 1 hour and 55 minutes, and here it is, 1 hour and 42 minutes. Guys, if you can do this, you can do anything, okay? Got to believe in yourself. You can do it. I wish you guys the best of luck on your test, and keep studying, keep pushing. Watch this video, watch the parts that you need as many times as you need to. I hope you guys do well on your test, and we'll see you on the next video.